Okay, for number 4, it's a fourth degree polynomial, and I'm looking for critical points and min-maxes, all right? So looking at it, yeah, it might be hard to graph, but I'm not going to graph that. I'm going to say f of x is given. Let's write down f prime. What do you get there? You get 3x cubed. That's a cubic, by the way. Plus 6x squared. And then you're going to get minus 3x. All right? And then minus 6. Now, in general, you know, what you learn in Math 119 is probably going to be applicable here. I'm going to just try to factor it. And looking at it, I don't know. I'm going to say 3x squared from the first two terms. And what do you get there? X plus 2. Let me just check that out. You'd get 3x cubed plus 6x squared. I'm going to factor out a minus 3 here. And what do you get? X plus 2. Let's just check it. You get minus 3x minus 6. What do I get there? X plus 2. It's a common factor. And then you get 3x squared minus 3. Well, I think I keep moving along. This is x plus 2. And then you get 3. That'll be x squared minus 1, which is x plus 1, x minus 1. That's a complete factorization of f prime. I'm going to start writing the zeros down. You know, plus or minus 1 certainly. And the other 0 would be at minus 2. I'm going to test it out. And this is the derivative for testing out. I got 3 critical values, 1, minus 1, and minus 2. And let's check it out. So after 1, I'd pick, I don't know, 2, plug it in. You're going to get positive, which means the original function, f, is increasing. Between minus 1, I'd pick 0, and you get positive, 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 negative. Overall, it's negative, decreasing. Now, if you go between minus 2 and minus 1, I'd say like minus 1.5, positive, positive, negative, negative. It will be positive. If you go between below minus 2, like minus 3, plug it in, negative, negative, positive, negative, negative. Oh, negative. Okay, what do I know about this over here? My critical points, let me write this down for you, minus 2. I'm just going to write down f of minus 2. I'm not going to compute it. And what's that going to be? Minimum. I'm looking at my diagram over here. Okay, let's do f of minus 1. I'm sorry, minus 1. F of minus 1. What's that going to be? A maximal point. And these are local, by the way. All right? So let's keep going. Let's do the minimum. The minimum occurs at 1, f of 1. And again, these are all local. By the way, I know the shape of this thing over here, indicating that there is a shape to it. I'm not exactly sure what the shape is, but I do know it follows this pattern that I'm seeing over here. So something like this over here. Now, by the way, I'm not saying that this is lower than that. Now, what do I know about this over here? This is clearly a local max. These over here, you know, you can compute the numbers and determine which one's the global one. And I'm just not going to compute it because they really asked for that, right? So find the function's critical values, we did that. Use the first derivative test, we did do that. Determine the critical point is local or local minimax, and we did that. So let's take a look at the key and see if we've done okay. And I'm looking at it, and we got the, you know, minus 2, minus 1, and 1. I got those 3 listed over here. All right, what else? Simple sign else first derivative. I did that. A maximum occurs at minus 1. I got that written over here. What am I going to say? The minimums occur at minus 2 and at 1. Thank you.